A, B, C, L, M are vectors, prove that the box product of A, B, C into L cross M is equal to the determinant, the elements of which are A, B, C, A dot L, B dot L, C dot L, and A dot M, B dot M, C dot M. So we have been given 5 vectors A, B, C, L, M, and we have to prove this relation. Let us take the vectors A, B, C, L, M as A equal to A1 I cap plus A2 J cap plus A3 K cap, vector B as equal to B1 I cap plus B2 J cap plus B3 K cap, vector C as equal to C1 I cap plus C2 J cap plus C3 K cap, vector L as equal to L1 I cap plus L2 J cap plus L3 K cap, and vector M as equal to M1 I cap plus M2 J cap plus M3 K cap. Now the box product of A, B, C is equal to the determinant A1, A2, A3, B1, B2, B3, and C1, C2, C3. Also L cross M would be equal to the determinant I cap, J cap, K cap, L1, L2, L3, and M1, M2, M3. And we have to find the product of these two determinants. So we take this box product into this cross product, and this would be equal to the product of these two determinants. Now when we multiply these two determinants, we get the elements as A1 I cap plus A2 J cap plus A3 K cap, A1 L1 plus A2 L2 plus A3 L3, A1 M1 plus A2 M2 plus A3 M3. Similarly, the second row elements are B1 I cap plus B2 J cap plus B3 K cap, B1 L1 plus B2 L2 plus B3 L3, and B1 M1 plus B2 M2 plus B3 M3. Similarly, the third row elements become C1 I cap plus C2 J cap plus C3 K cap, C1 L1 plus C2 L2 plus C3 L3, C1 M1 plus C2 M2 plus C3 M3. Now this is nothing but vector A, this is nothing but A dot L, this is A dot M. Similarly, this is vector B, this is vector B dot L, this is B dot M, and similarly this is vector C, this is C dot L, and this is C dot M. Therefore this determinant becomes A dot L, A dot M, B dot L, B dot M, and C dot L, C dot M. Now the box product of A, B, C into the cross product of L cross M is equal to the determinant, elements of which are given by A, B, C, A dot L, B dot L, C dot L, and A dot M, B dot M, C dot M. The second type of triple product is the vector triple product. Earlier we have seen the scalar triple product, which results into the generation of a scalar quantity. Now this triple product would generate a vector quantity. This vector triple product is defined as A cross of B cross C. So first we get a B cross C, then we again get a cross product with another vector A to get the final A cross B cross C. Let us say that this is the plane in which the vector B and C lie. Let us say that this is the plane and in which vector B and vector C lie. So now this is vector B, this is vector C. Now we see that the cross product of B and C would be B cross C, and this vector would be perpendicular to the plane of B and C. So B cross C is a vector which is perpendicular to the plane of B and C. Now again, if we take the cross product of A with this vector B cross C, then this would generate a vector A cross B cross C, which would lie in the plane of B and C. Thus we see that A cross B cross C, B and C are coplanar vectors, that is, they lie in the same plane. So A cross B cross C results into a vector which is coplanar with B and C. Now as these three vectors are coplanar, we can write A cross B cross C equal to M times B plus N times C. Here we have taken this vector as a linear combination of B and C. Let us say that this is equation number 1. Now what we do is we take dot products on both sides with A. So A dot A cross B cross C would be equal to M times A dot B plus N times A dot C. Now this vector A cross B cross C is perpendicular to the vector A. Therefore their dot product would be equal to 0, as the angle between these two vectors is 90 degrees. Thus this would be equal to 0, and hence we can get M times A dot B plus N times A dot C is equal to 0. Let us say this is equation number 2. So from 1 and 2 we get A cross B cross C equal to A dot C times vector B minus A dot B times vector C. Thus A cross B cross C is equal to A dot C times vector B minus A dot B times vector C. This is a scalar quantity and this is a scalar quantity. Similarly, bracket of A cross B cross C would be equal to C dot A times vector B minus of C dot B times vector A. Thus this is the value of A cross of B cross C. Now let's try to solve an example based on the above concept. This problem appeared in iitjee 2004 and it says that if vector A is equal to I cap plus j cap plus k cap, also A dot B is equal to 1 and A cross B is equal to j cap minus k cap, then vector B is, option number A is I cap minus j cap plus k cap, option number B is 2 times j cap minus k cap, option number C is I cap, and option number D is 2 times I cap. So in this problem we have been given vector A, also the dot product of A and B is equal to 1 and the cross product of A and B is equal to j cap minus k cap. We have to find what is vector B and we have been given the 4 options. So let's see the solution of this. Given that vector A is equal to I cap plus j cap plus k cap, also A dot B is equal to 1 and A cross B is equal to j cap minus k cap. Now we know that A cross of A cross B would be equal to A dot B times vector A minus A dot A times vector B. This is the expression for vector triple product between the vectors A and B. Now vector A is nothing but I cap plus j cap plus k cap. So I cap plus j cap plus k cap cross, we know this value is equal to j cap minus k cap. So this would be j cap minus k cap equal to A dot B is nothing but 1. So 1 times vector A minus A dot A is nothing but the square of modulus of vector A or the square of magnitude of vector A. So this is modulus of vector A whole square times the vector B. Now when we cross multiply this, we get k cap plus j cap plus 0 minus I cap plus minus of I cap plus 0 equal to vector A is I cap plus j cap plus k cap minus, now the modulus of vector A is equal to root 3. So this would be equal to 3 and thus minus of 3 times vector B. Thus from this we get 3 times vector B is equal to 3I and so B is equal to I cap. Thus the value of vector B is equal to I cap. Let's try to solve one more example. This problem appeared in iitjee 1997 and it says that show that B cross C dot A cross D plus C cross A dot B cross D plus A cross B dot C cross D is equal to 0. So in this problem we have to show that this expression holds, where A, B, C, D are 4 vectors. Now we have to show that B cross C dot A cross D plus C cross A dot B cross D plus A cross B dot C cross D is equal to 0. Let us say that B cross C is equal to vector U, C cross A is equal to vector V, A cross B is equal to vector W. Now we can write it as U dot A cross D plus V dot B cross D plus W dot C cross D, or we can write it as U cross A dot D. Now we can interchange the sign as we know this is a property of scalar triple product. So U cross A dot D plus V cross B dot D plus W cross C dot D. Now U is nothing but B cross C. So B cross C cross A dot vector D plus C cross A cross B dot vector D plus A cross B cross C dot vector D. We have substituted again back the value of U, V and W here. Now this vector triple product is equal to A dot B times vector C minus A dot C times vector B dot vector D plus B dot C times vector A minus A dot B times vector C dot vector D plus A dot C times vector B minus B dot C times vector A dot vector D. This gets further simplified to A dot B into C dot D minus A dot C into B dot D plus B dot C into A dot D minus A dot B into C dot D plus A dot C into B dot D minus B dot C into A dot D. We see that all these terms gets cancelled and this is equal to 0, and hence we have proved that B cross C dot A cross D plus C cross A dot B cross D plus A cross B dot C cross D is equal to 0. Now let's try to understand what is the reciprocal system. Now first of all let's consider 3 non-coplanar vectors A, B and C. Now we consider 3 more vectors, A dash which is equal to B cross C divided by the box product of ABC, B dash equal to C cross A divided by ABC, and C dash equal to A cross B divided by ABC. So we consider these three vectors A dash, B dash and C dash such that A dash is equal to B cross C by the box product of ABC, B dash equal to C cross A divided by the box product of ABC, and C dash equal to A cross B divided by the box product of ABC. Now if we take the dot product of A at A dash, then what we get is 1. Similarly, B dot B dash would be equal to 1 and C dot C dash would be equal to 1. Thus, we see that A and A dash are reciprocal of each other. B is equal to 1 by B dash, and so B dash is the reciprocal of B, and similarly C dash is the reciprocal of the vector C. So such a system of A, B, C and A dash, B dash, C dash are called as the reciprocal system. Now let's see some of the properties of the reciprocal system. The first is the box product of ABC into the box product of A dash, B dash, C dash is equal to 1. Why this happens? We know that A dash is equal to B cross C divided by ABC. Similarly, B dash is equal to P cross A divided by the box product ABC, and similarly C dash is equal to divided by ABC. Now the box product of A dash, B dash and C dash would be equal to the box product of B cross C divided by ABC, C cross A divided by ABC, and A cross B divided by ABC. Now we can take ABC common and get ABC whole cube, vector A, vector A, B, vector A, vector B, vector C into B cross C, C cross A